I want you to consider the integral of 3 over x times x plus 3. Or even, let's say the integral of x minus 1 times x plus 3 dx.
Are we doing 5A?
We're doing 5A, yes. Where's my vector clicker? So I want you to look at this and tell me what are some thoughts on what you would do. How would you integrate this? Anyone? Well, I'll give you a little hint. First of all, the x's are where? In the denominator. So whenever we have some form of x, like 1 over x in the denominator, what is the antiderivative of 1 over x going to be? Natural log of x. But the problem is what? We have multiplication going on. So we could try to multiply this out, but then we would run into other issues. If we multiply this out, then we have 1 over a quadratic, and then we have to anti-differentiate the quadratic and divide it, and we don't necessarily know how to do all that yet. It's just something we haven't learned. So instead, well, what if we could just split this in half? As we all know, 1 over 2x plus 1 over 3, can you add these two together? No, but what can you give them? The same denominator. We would get 1 over 2x plus, what do I multiply both of these by? 2x and 2x. I would get 2x over 6x. What do I need to multiply this by now? 3 and 3. Therefore, I get 1 over 6x plus, 3 over 6x plus 2x over 6x to equal 3 plus 2x over 6x. We basically took two fractions and combined them when they had different denominators. Now what about this case? If I have 2 over x minus 3 plus 3 over x minus 2. Well, how do I combine these two now? How do I combine 2 over x minus 3 and 3 over x minus 2? You just have to give them a what? The same denominator. What denominator do we want? Well, the easiest one is just x minus 3 times x minus 2. Over, what do we multiply this by? X minus 2. This we multiply by x minus 3. I would get 2x minus 4 plus 3x minus 9 to equal 5x minus 13 over x minus 3 times x minus 2. Now if we look at this, we took this here, and could you pretty easily differentiate these two? Could you? So not differentiate, anti-differentiate these two. Yeah, because the anti-differentiation of this would just be natural log of x minus 3, 2 in the front, natural log of x minus 2, 3 in the front. So what we're going to be doing today is we're going to be going from here all the way back to here. We're going to be going backwards. Instead of combining two things to create a fraction, we're going to be taking a fraction and pulling it apart. So, partial fractions is the reverse of combination fractions, where we combine two fractions here. Okay? So, we already saw up here how we would actually combine fractions. I kind of accidentally did this part over here, so if you want to take this and jot it down right down here, we can do 3 over x minus 2. Was this what we had here? All right, 2 over x minus 3 plus 3 over x minus 2. Multiply this side by x minus 3 over, sorry, x minus 2 over x minus 2, x minus 3 over x minus 3 equals 2x minus 4 plus 3x minus 9. Okay. So now I want you all just to see. Thumbs up if you understand everything I just did. Thumbs sideways if you got the right idea but aren't fully on it. Or thumbs down if I just did some voodoo magic in front of you. Okay, so we all feel pretty good about dividing fractions? Now let's talk about partial fractions. Okay? Now we get into the fun stuff. So, let's say we have this here. Oops, need to do attendance real fast. Faith is gone. Alice is ready. So, here we have the big function of 6x squared minus 8x minus 4 divided by x squared minus 4 times x minus 1. Let's say we wanted to integrate this somehow. Do you think you could integrate this right now? No. We're dividing two things. We're multiplying two things at the bottom. There's way too much going on. So what we're going to do first is we're going to break apart the bottom. I'm going to look over here and say, okay, well, what can I do? Well, the top, I don't care about the top. Just keep it as is. But the bottom, I'm going to factor as much as I can. I'm going to try to get these all down to linears. That will help. Make sure to get these all down to linears. So how can I factor x squared minus 4?
X plus 2, x minus 2.
So we get x plus 2 times x minus 2 times x minus 1, all on the bottom. It's 6x squared minus 8x minus 4. And what we know is, well, if you look up here, we had two fractions on the bottom, two different parts. And how many fractions did we start with? We started with 2. So here we have 3 things on the bottom. So how many fractions should we have? 3. So I'm going to write this out. So we have a fraction of x plus 2 plus, a fraction of x plus 2. And then we have plus a fraction of x minus 2 plus a fraction of x minus 1, which is going to equal our function, our f of x. This thing over here, if I add all these together with whatever's on top, I should get these equations. However, what do we know? Do we know what's on top? So what do we do when we don't know something? We give it a value, a variable. So what's the variable I'm going to choose? We like to do capital letters, so A, B, and C. So I can always write this out. I can separate this into fractions with an A on the top, B on the top, and C on the top. Now what I want to do is I want to take these, and I want to state, well, I know that A over x plus 2 plus B over x minus 2 plus C over x minus 1 is going to be equal to 6x squared minus 8x minus 4 divided by x plus 2 times x minus 2 times x minus 1. Oh my gosh, this looks so complicated, right? Let's uncomplicate it. Let's somehow, I want to get rid of all my denominators. How would I get rid of all of my denominators? What would I need to multiply by to get rid of every single thing? What was that? I heard someone say the correct answer.
All of them?
Yeah, It is all of them. If I multiply by x plus 2, x minus 2, x minus 1, what's going to happen? All of these are going to cancel. So I'm going to go ahead and do that. You multiply by this. And you should get a format that looks like so. If I multiply by that, well, what's going to cancel here? What's going to cancel with the a? The x plus 2. So if I multiply by x plus 2 times x minus 2 times x minus 1. If I multiply by this, I'm going to get, well, the x plus 2's are going to cancel, and I'm going to have a times, what's left over? X minus 2 and x minus 1. So I have a times x minus 2 times x minus 1.
What if they all cancel with each other though?
So this cancels here completely, right? Mm-hmm. And then they cancel these. So if you notice, this will cancel with x plus 2, this will cancel with x minus 2, and this will cancel with x minus 1. So we get a times x minus 2, x minus 1, plus b times x plus 2 times x minus 1, plus c times parentheses are always rough with this, x minus 2, or sorry, x plus 2 times x minus 2. So basically, the shortcut version of this is eliminate whatever it's over and multiply it by the rest. So a has x plus 2, so I'm only going to multiply it by x minus 2, x minus 1, and so on and so forth. And then when I multiply on the other side, I get equals. Well, what happens to this entire thing? It cancels. We do not need to factor, don't worry.
Oh, no.
Nope.
Oh, yeah.
So now we have to consider some hypotheticals. Let's say we have this. Can we solve for x in any way here? Can we solve, well, not x. Can we solve for a in any way? Or b or c? No. However, notice, what do a and b both have? They have x minus 1. What do b and c both have? They both have x plus 2. Notice that all of them have at least one thing in common. So what I'm going to do is I'm going to start looking at, well, what do I need to input for x to cancel all of these out and leave only one? Well, let's start with this. What am I missing? What does a not have? A does not have. So therefore, what if I input x equals negative 2? So what we're going to do now is if x equals negative 2, then, well, what's going to happen to b? We get negative 2 times b, which is 0. What happens to c? Negative 2 times c, which is? So what is the only thing we have left? A and this other side. So we get a times, then we get a times negative 4, because negative 2 minus 2, times negative 3, plus c times 0, which cancels. Doesn't even matter what the other one is. Sorry, plus b times 0, which cancels, plus c times 0, which cancels, is equal to, and now I just need to input the negative 2 into the other side. So I'm going to get 6 times negative 2 squared minus 8 times negative 2 minus 4. I get negative 12a equals, let's say positive 12a equals 36. Therefore, what is my a value equal to now? A equals 3. So we already know, if we go all the way back here, what is going to be up here, Caleb? 3.
But that's only at negative 2.
But the thing is, at negative 2, it's not only at negative 2, it's just that using negative 2, we were able to find what a is going to equal. It's not only at negative 2. Using negative 2 helps us find the rest of the values. Because, what? No, not for A, because if we use -1, would A have this
Or
have canceled?
positive one.
We positive one, you mean?
Yeah.
So you have to use something that's going to give you 0. If you look here, what's going to give you 0? 2, 1, or
Let's do apply for both.
-2.
So would we use +1 to find C?
Exactly. Now let's go ahead and find B. So for B, what does B not have? B does not have, let's check it,
X minus 2.
x minus 2. So therefore, what should we input?
2.
2. If we input 2, what is going to happen? If x equals 2, then A times 0 cancels, plus B times, and again we're going to input 2, so we get 4 times 1, plus C times 0, which cancels, equals 6 times 2 squared minus 8 times 2 minus 4. And Caleb, I don't have the best way to answer that question of yours. The idea is it's not just that x equals 2, but using x equals 2, because when x equals 2, what's going to be true about B and C? They're going to cancel, right? So because of that, I can then solve for A.
Yes.
You can just always do that.
Just because.
I'd have to look through the process and get more familiar with it to say exactly why. But the idea is we use the points, or sorry, we use the x value that will cancel in order to get down to that point, and that just works. I'll see if I can get a better explanation. But yeah, yes, Connor.
Is the x equals 2 for B?
Yes, x equals 2 because what is that missing? We're missing x minus 2. So what's going to give me a 0? 2. So 4b is equal to 4. Therefore, b is equal to 1. Now, what's the last one we need to do if x equals? Positive 1. Then I know that my a is going to cancel, my b is going to cancel. I'm not even going to write out my c. My c is going to be 3 times -1 equals 6 times 1 squared minus 8 times 1 minus 4. -3c equals -6. Therefore, c is equal to 2. Now this looks like a lot of work, doesn't it? Pretty big. I will say that this is a bigger one than you usually would see. But once you get good at these, they're not that bad. Yes.
When's our quiz?
Our quiz should be on Tuesday.
Is this on the first?
Do we have?
Yes. Yeah. We have full weeks until spring break. Now, to finish this off, well, all I need to do is rewrite this. What is my a value? Someone shout out my a value? 3 over x plus 2 plus, what's my b value? 1 over x minus 2 plus 2 over x minus 1. And that is my final answer for this. Hooray! Now, all we need to do to finish this is go to the next part. Well, can we easily integrate this now? The answer is yes, we can. So let's go ahead and do this. We have the integral of 3 over x plus 2 plus 1 over x minus 2 plus 2 over x minus 1 dx. So we basically took this large equation here and reformed it into this slightly simpler one. Because now what do we have? We just have a bunch of natural logs that we can just use. So what is the integral of 3 over x plus 2? What's the antiderivative?
3 natural.
It's going to be 3 ln of, and then is there anything you have to worry about? What's the derivative of x plus 2? Just 1. So therefore, do you need to worry about anything? No. So therefore, 3 natural log of x plus 2. Sorry. Make sure you put the absolute values around it. Plus 1 natural log, or just natural log of x minus 2, plus 2 natural log of x minus 1, all plus c. And then obviously we have to do our rules. What can I do with the numbers in front of the natural logs? I can bring those to the top. So this becomes cubed. This becomes squared. Okay? And then if we are adding on, if we're adding these, adding is the same as what for logarithms? Adding is the same as multiplication. So I can rewrite this as the natural log of the absolute value of parentheses x plus 2 cubed times x minus 2 times x minus 1 squared, absolute value plus c. So that would be our integral there. Now, Roland, are you there? Roland, how much do you think this shows up when you have to do partial fractions? A decent amount. So get comfortable with these because a decent amount is a good amount. Especially in BC. Once you get to BC, integrating like this is going to be very, very common.
Can we go over the natural log rules real quick? I kind of forgot them
Which rules are you talking about?
Just the natural log stuff.
It's natural log and log stuff. Well, for natural log, it's just if you have a number in front, it can become a power.
Yeah.
And if you have addition and you're adding logs, you can multiply their insides. If you have subtraction, you can divide instead. Those are the big ones that you really have to know. If we have any more, once we get to the end of this year, we can start doing more revision on that stuff. I want to get through all the content first, though. Once we get through all the content and we get to the end of the year, then we can start being like, all right, let's go over our exponent rules. Let's go over our logarithm rules. Let's have a day on trigonometry again, where we're not going outside. Because last time we tried that, you're like, give us a trick day, Mr. Holm, and then you went outside and I lost
Jeez,
them.
I learned so much.
What's the sign of pi? Yeah, that's it.
Wait, whoa. One. No, zero.
The fact that you had to think about it makes me sad.
Wait, is it 1 or 0?
Wait, which one is it? It's zero.
Great question.
It's zero.
I don't know, maybe you had a trick day, you would know, huh?
It's zero.
Okay, everybody, let's go ahead and
I think we have calculators.
turn to the exploration, not on the AP.